what exactly three major things. Design can be done in JSS, manufacturing in Taiwan, again WASAT in Cairns in Mysore can be done in the future. I think you got the ecosystem, right? Very at the very high level, the ecosystem is like this. JSS with all cadence synopsis tools here in the lab in a center of excellence for chip design can make a chips. Faculty and students can make a chips. Can have in India with Semiconductor Complex Limited or Tata Foundry or TSMC also even today. Then send the GDS to or a layout to them. Then get it fabricated and test it in Cairns in Mysore. So I think the ecosystem is there here, right? So this is what the ecosystem is. What briefly what I want to mention. Then again, this is what exactly saying. So there are original chip makers with fabrication facilities. Examples are Intel, AMD, and all. They design their chips and they manufacture their chips and they test their chips on in all their own facility. But there are also fabless companies where the foundry is not there. For example, Qualcomm is the biggest fabless company. Qualcomm does not have a fab of their own. And again, if we have a startup, for example, in a college, if we have a startup, we cannot be a fab company because we cannot invest 40,000 crores to establish a fab. Of my students, 3 students and two faculty from JSS start a fabless company. They make a chips. They have in India with a foundry. They tape out the chips. They will sell it, but they don't own a fab. They will depend upon the contract manufacturer for fabrication. So such kind of companies are there in Bangalore. Several companies are there. In fabless companies do exist and a lot of coming up. Many companies are coming up in a fabless way because they want an Indian microcontroller. The government wants an Indian microcontroller. Means okay, let it be the fabless company, but we want a company which, for example, if you take any microcontroller today, it's not Indian. NXP, NSS, Infinia, all these microcontrollers are not Indian. That's what the primary worry today. So now we have a list of startups who are promising to bring the microcontroller from Numizo Semiconductors to many companies are there. For example, then again, because company cost is 10 crores, Synopsys will give them 100 crores and acquire the company is closed. That's all. Now, means who wants and if you are getting 100 crores for a 10 crore company. So that is how the Indian IP companies and Indian mineral companies like Magma were built. Because they have a big pockets, they have local Synopsys or a cable and just buy Indian Indian IP companies or EDA companies. But we are not there in the microcontroller market. We have to design Indian microcontroller is required. Now there are many startups in the ecosystem for this purpose. Chinese model is closed actually. The Chinese model is closed. Even if you don't, even in a non-tech area, they are very closed. Very closed actually. Because see, for example, our in the stock markets, right? For example, Bombay Stock Exchange is more transparent than Bombay Stock Exchange. Anybody can really know what is happening in the BSE, but foreign is completely closed actually. That's the reason why foreign investment will come to BSE. In the last year, very China, especially the foreign institutional investment, FIIs, not FDI. Direct investment is China is still number one, but foreign institutional investment. That is why I want to buy a company of, I want to buy a share of Infosys, I want to buy a share of Wipro, I want to buy a share of other Indian companies like Tata Motors, etc. European and American investors come around and buy these Indian company shares in Bombay Stock Exchange. In a similar way, we will risk taking a share of a Chinese company in Bombay Stock Exchange. No. FIIs are, India is far ahead because they are transparent. And when you can to acquire company, they cannot acquire Bombay in India. China is not possible. Okay, correct. Exactly. For example, I can see a macro design automation which was founded by NTT Allen, which gave a literally breathless competition to the Cadence and Mentor, which even Synopsys. That was acquired by Cadence, acquired by Synopsys and Cadence. I don't remember now. It happened 15 years back. I was very worried. I was the first person, as a master student, I was very worried because not every company died. Acquired by one multinational company like Cadence or Synopsys. So I'm speaking openly without any this one because it's all the same. We have from the same tribe, teachers. So that's the reason I'm speaking openly. I think no corporate person is there to sue that for the words I'm saying. So that's what I'm saying is fine. Then again, this is what is happening in the IP services, IP design companies and media companies. Then finally, let's come to the manufacturing. In the manufacturing, we generally depend upon now the cutting-edge technology is there with the maximum performance for the best of my knowledge is TSMC, Taiwan Semiconductor Manufacturing Company, and Global Foundries. Global Foundries is a multinational company has got a facilities in South Korea and America, etc. But TSMC is not in Taiwan and again now they are set up in America, etc. But Motorola had a really big fat so now so what? 30 years back, which I was making. So I know that I was very happy to know when I was a master student looking at our resume, I was in 1996 you only in Motorola Arizona, which got closed very easily, completely destroyed. So now we have to depend on contract manufacturers, but can we do anything else? For example, the chip which I showed in my slide, right? This one. This slide is there. This is the ADC for anti-corruption. Basically, it works from Bristol, Bristol, Calcutta. This is the current control for Massachusetts. So this got taped out in UMC in 2009. 2009, we sent to the UMC, we got 20 chips back and we tested it. Then I was out to give a diploma for master's degree. Until unless you tape out, you won't get degree. That was the condition of my professor. So that time we had a UMC, but still costly that time. The government funded the tape out. The question is now, for example, Genesis want to do the tape out. How can we do the tape out? We can easily have an NDA with Semiconductor Complex Limited, which will give the enable technology completely free of cost for us. And again, if you want to do the tape out, it's just only the 3 lakhs. 3 lakhs you spend in the 10 license to make Semiconductor Complex Limited, the knowledge and technology. We can easily announce that as an engineering college story, I can say that we have a tape out. Our students design chips. Not only design chips, yeah. SCL Mohali, yeah, SCL Mohali. SCL Mohali actually it's a sad story and also a good story. SCL Mohali acquired other small developers, production line, production line and preparation. So I take out few chips from enable Uttarakhand as a permanent industry. So it's a good for me. It's not most of the chips, or at least 20 to 30% of the chips today are installed in the satellites in rocket launching missions comes from this year. 30 to 40% chips. It's indigenous chips. Bell was actually the BJP process. No. They have actually the Bell was doing something else. Actually, you know what science was in IAS, right? Or there was another in factory care for not called as a star. Society and the DRDO. Society Semiconductor Technology, some lab is there in this one. So that is what exactly the science does for it. The same video was doing few years back, making sample of digital design. They were doing the same what science does today in IAC. Frankly speaking, by the 1989, SCL was doing very great. Intel was manufacturing chipset 600 nanometer technology, and SCL in 1989 was manufacturing chipset 800 nanometer technology. Almost we are there. But the fire accident in 1989 in SCL killed the SCL for next 8 years. And 8 years, in 97, 98, there was no activity in SCL. The fire accident in 1989, we were there at 800 nanometer technology, but we got the side story. Okay, let's come back to the topic. So, the contract manufacturers we depend upon, and but maybe so as an academia we can develop a chips and SCL. It's for India for taking out 10 or 20 chips, 3 lakhs or 4 lakhs, easily we can spend. I think most of the colleges, most of the engineering colleges can spend 2 to 3 lakhs to before it. And again, the cadence tools will be there. The only thing is, the job is take the easy to make sure that libraries are integrated with the tool properly. Go for a simple design, don't go for any other. Let's take out a pan first. Let's take out the inverter first. Let's have a that's what we need to do actually. So, and again, there are research and mathematics for this classical example sense. Whenever I need any capacitor circuits for the sense and IAC, request the background and 10 times make it happen. So, this is what exactly we are doing here. But fortunately, we will have another 130 foundry coming up in Gujarat with Tata something else, but it's a commercial program. But let's, as an academicians, we depend upon it. It's better easier. The next third ecosystem of the design, after manufacturing, the WhatsApp, that is the outsourced and assembly and test. In this, we do wafer sorting. That is, once the wafers get printed in the wafers get printed in the foundry, and you want to get the test it, then dice it, then package it like this. All these jobs are done in WhatsApp. When I was a ministry scientist, I was all fighting all with my joint secretaries, other secretaries, is that don't go and ask any company to bring a foundry to India. Nobody will come. Go and ask all WhatsApps to come to India. Go to a Singapore, ask them to do WhatsApp. Once you have WhatsApp, they will run to the so family came in Japan. Tata also family started in Goa and Alan also is staying in Assam. At least in Karnataka we have one community working in Goa, Tata also. And one family came in 6 months or 1 year ago is working at so WhatsApp we have let's take 50 ATM machines let's say. Each WhatsApp will have 20 ATM machines. Each ATM will cost 10 to 50 crores. You multiply it by how many ATM machines you have. At the same time, all your furniture, and the facility is quite different. You also put consolidate the understanding. It's a costly effort to. It's not building a WhatsApp is not a problem. Maintaining a WhatsApp is a big problem. If you do any small anti-static violation, all chips will get destroyed, etc. The problem of not having a money to build a WhatsApp area, but the 50 hertz promise from the Westcom is really important. It should not be 48, it should not be 52, or 49 or 51. That is also a problem in India actually, if you maintain the sat in India. So this is what exactly now many people are betting, like the number on Westcom and all, and ensure that 50 years is means great means what is that? They like also the bravery. Means what is that? Strong heart. Yeah, strong heart people. So the also sorting, packaging, and testing apples and website. So now what is the question is how do we employ our students in website? What should we teach our students to get employed in website? For example, Keynes and Tata website. It's only two examples, Keynes and Tata website. Another 10 websites will come to India. Majority are starting, two are there as of now. Another 5-6 will come easily in next 2-3 years. Then what should we do? What should, as a faculty, what should we do? Then what should we do to ensure that our students will get job into this? Change the syllabus, introduce post-silicon validation, get the small testers into the lab, ensure that what exactly done in the research work in your lab, and introduce post-silicon validation as a subject, as a elective first, then make it as a core at some point, and ensure that we teach LIC very well, we teach ACP very well, we teach network analysis very well, and teach post-silicon validation very well. Then it makes sense. It makes sense. That is what required exactly in the required. Then again, teach PCB design. If it is not done, you do PCB design also. That's right. With these skills, we can employ our students on the side. We can go and sell our students to the side. That's what our job is, right? We have to sell our students to companies. We employ our business jobs. Okay, next I will come to the another. Yeah, please. Yeah. Yes, sir, very much, very much, very much. Actually, your side is not a very thing. I went to statistic part work and that 2012 I was in several working the statistics part in our side. It's not great. I don't think. If you can do the right software, then of course, if you can do rocket science and so on, some science, yes, the same is not great thing. We can do one more thing is we need what is that? And manpower may be there actually. That's all. The quality manpower may be there. If you go and see any WhatsApp production, it was running by you don't see WhatsApp, you don't think of WhatsApp, you don't think testing assembly. It was founded by statistic pack was founded by India. That means they are converted to a simple consensus, but they are only reasons for various commercial reasons. But they are all Indians. They are all Indians. Now most of the WhatsApps are founded by Indians, even Singapore, Philippines, and Malaysia. So if they can found an WhatsApp over there, they can move WhatsApp here also. WhatsApp here also. No problem about it. So the next I will come to the why startups in design space is challenging. The question is, the answer is simple. Gestation periods are very high. Gestation periods are very high because the chip startup in AI is uniform. It takes 3 years. But Indian venture capitalist needs a human delivery in 9 months. That's what actually something like elephant delivering a paper of countries startup will succeed. And any electrical engineering company will succeed. And I'm not talking about the chip design, it's pure engineering system company, electrical and instrumentation power company. It's a gestation period. So no venture capitalists want to come forward. The simple reason is what that funded or what they know is funded. The simple reason is me, my students, 3 students, and myself, we founded a company and this other venture capitalist, and we did not get funded, but we are trying something else now, but we are trying something else, but why we got rejected. Simple reason is another company what got funded, That company was app development company for PC searching, PNS searching. The company idea with what funding was, which was a mobile app for searching a paying guest in the Bangalore city. That got funded. And our chip design startup did not get funded. Simple reason is in 7 months you can see a cash flow there. A venture capitalist can see a cash flow in 6-7 months there. But not in the chip design company or embedded system company or implementation company. So that's what exactly is doing. The problem is the bottom line is the social players are really high. But we have to bear with it. There are a lot of venture capitalists today who want to fund the chip design companies if they see a potential problem, a potential team. They are not looking at the potential problem, they are looking at the potential team. Is the team capable? The team has a lot of good contribution or not? Team has a capability or not? If they believe in the team, they are funding it. But in other spaces, especially the app development or kind of gig economy startups, right? Gig economy startups are running some payment, etc. The gig economy startups, they are just seeing it an idea of money because anybody can do it. But in the case of a chip design company, we are not looking at an idea, we are looking at the capabilities, skills. So that's what exactly why the chip design startups are challenging. The fundamental problem is the cash flow we cannot see. It may take 4 years to 5 years to see the cash flow. The one classical example is the Tejas networks. If Tata would have not funded it, if Tata would have not taken stake in Tejas networks, by this time Tejas network would have been there. Tejas network is a good networking asset company. They had a great idea. They in the first 3 years, they had a fantastic product. At the same time, they got a lot of product. Then we thought of funded by Tata took a 30% or 40% stake in what the company is doing right now. The simple reason is it took 6 years to 7 years to build a cash flow in the system. The Indian startup, chips, Tata's chip startup. One classical example, took 6 to 7 years for a cash flow, to see the cash flow. So this is a kind of examples what we see here. The next another thing which I want to emphasize is the globalization of the semiconductor supply chain. It's not a supply chain, it's a design chain actually. Means we have an idea, we have a breakthrough, innovation happens. It's a simple understanding means that innovation happens in US, design happens in US, or the specification happens in US, the design, verification, physical design, timing analysis, power analysis, all the engineering happens in Bangalore, all India, specifically Bangalore, in the global business of Bangalore. Okay. Then again, you have a design, you have an engineering, you have a manufacturing, you have a WhatsApp here, you find Singapore, WhatsApp here, then Singapore warehouse, all chips are distributed. So the design happens here, means concept happens in warehouse. I think we have a concept happens in US, engineering happens in production happens in China, Taiwan, and South Korea. WhatsApp happens in Singapore and chips are distributed across the world. So this is a globalized supply chain. What it has led to? Because why people are doing like this? Just because to make the chips time effectively, cost effectively. I want to time effectively, I have to design the concept must be right, and cost effectively I have to do it. Only a time effectively, cost effectively to achieve the goals, the globalization will happen. Otherwise, why all engineering happens in India? It can happen anywhere in the world, it is happening in Europe because to make it cost effectively and time effectively. Then what are the problems connected with this? The problem connected with the globalization of the design chain is that hardware security problem. It's not connected with the cryptography, it's connected with IP infringement, counterfeiting, and reverse engineering. These are the already 10 years or 15 years old ideas I'm talking about. In 2020 and 2020, I solved, to help my PhD, I solved problem for it. For example, JSS, 3 students, 2 faculty come together and work. They came to the startup, they worked for 2 years, they designed a product. Then they send it to the KSMC. then got chips, tested it, Apple sold it, sold it to some customers, then what is going on. Company is going on. Suddenly they see a lot of chips on the market, this type of thing sold. How come these chips being sold? Because they have told the name of the TSMC, means TSMC is a trusted foundry, but you have given to them as a trusted foundry. Without their knowing, because he has a law of law, print another temporary analysis and present the name inside without their knowledge. We worked for 5 years in GSS, 3 students, 2 faculty, the startup. Worked for 3 years. Finally, we created a law for the foundry in some country. We don't have a, does it happen to the Qualcomm or any other company? No, it cannot happen because they have a resources for some person, in person will go to the foundry and also the layout is given, the layout is taken back. The startups don't have a resources, they share it on code. They take a copy and they manufacture 1,000 chips and sell it back to us. Without our knowledge, they manufacture 10,000 chips and sell it in the open market. So that is where exactly the startups die. They will buy it. They want to address this problem. Another ideal thing is, another big problem happens with startups in USA connected with this fabless model startups is the chip what we got 1,000 chips, we tested it and we sold it to the customers. The foundry guy, untrusted foundry, manufactured 10,000 chips, did not test it. In my name, he sold it to the some aeroplane company took the chip and they put it in the aeroplane. That plane will crash. Who is the designer of this chip? That particular startup. And company got into the integration, they have a case to prove that they sold it. They have to prove in the court that they have not sold the IC. Who cares, sir? Who cares if I go and buy a mobile phone, I'll take 4 years. Right? Yes, things are there, supply chain is there, but startups don't have the resources to keep track of it. Startups don't have any manpower or nothing is there for startups to keep track of it. So accountability is a big problem. If you are going for an IC company, ensure that you have a lock unlock of the functionality, etc., all security rules to ensure the chip is not counterfeited at the source. Not counterfeited at the source. There is another type of counterfeiting called as a recycle. When you go to a laptop, somebody laptop will get it. Then the researcher will go to the camera and so that's the secondary problem. And also I take Kavina and Diana, I take there's a different story. Okay. So the next is what is happening in the advancements in the chip design? The advancements in the chip design is already the people have talked about 3D chips, 3D chips, chipsets in the morning. Many people have spoken, stalwarts have spoken about it. I don't want to get into that. So this is the most recent microcontroller from the mainstream. Is that you will see 20 years back when I started my career, I did not see something like a security. Whatever it is there, right? Security was not there. Something like network acceleration was not there. I may have a CAN empty protocol 20 years back or 12 years back. CAN protocol was there in microcontrollers. XC12 in 1995 had a CAN controller. But the question is, the problem, what extra was this something the word called as a network acceleration. Here there is something called as this security engine or security accelerator. This is where exactly the how the chip differs 20 years back and in 2005 and 2025. We have an accelerator here. We have an accelerator here. So this is one new process. Another thing which I want to show is we have a multiple process, many cores. Means 3x dual core or a cluster lockstep option. We have a multiple cores, 4 cores, quad core, octa core, etc. So this is the complexity of today's microcontroller. So again, example of PDIC, PDIC, I don't want to get into this one. Now what is the difference between 2.5D and 3D, something like this? You have an interposer circuit and then you have the power components. Your logic may be 14 nanometer technology or RF may be 25 nanometer technology. Your memory may be still 28 nanometer and your MEMS may be 300 nanometer. Typically 300 technology. You can see it on a single interposer circuit. You have a MEMS with 350 nanometer technology and a logic with 14 nanometer or 7 nanometer technology. So that's what exactly this 2D is 2.5D is. But 3D IC is simple. It's something like you have a TSVs or silicon boards, micro boards, and all the time. Simply get a 3D IC. So the whole interposer makes a 3D. With interposer it makes a 2.5D IC. But the problem is designing this interposer is not a simple thing. It's a risks are there. But at the same time, what is the challenging thing here is the testing, real-time testing. Real-time testing on the brain chip, you can do testing on 2.5D IC or other separate kind of repository like students can be tools and protocols like a library, etc., etc. All we need to get the testing is not easy, and we need to test less than 1 second, whatever the complexity of the chip. So this is again a different diagram. Again, this is a different diagram. It's a chiplet approach. Earlier this was a monolithic. Now we have a different chiplets like one chiplet, monolithic, CPU, etc., etc. Now this is one part which morning also professors discussed. The next, I will come back to the last variation like Moore's law. We know exactly Moore's law prediction. Now how the Moore's law was predicted, which is pipeline. But Moore's law actually what happened? It has reached its limits. Moore's law is there. It's no more the it's no more a free lens. Means for example, why people call it as a free lens for the simple reason is how do you improve the performance? How do you improve the performance? By reducing the channel length. Reduce the channel length of the MOSFET, the MOSFET will become faster. Once the MOSFET becomes faster, the same design which you are operating at 150 megahertz, then you operate at 200 megahertz. If you scale down from 180 nanometer to 150 nanometer, the same design, I don't want to change the design. Just 180 nanometer design, I will just re-engineering the 150 nanometer technology. Then chips easily will gain 50 to 60 megahertz faster chips. Get ready. Don't tell the customer that it's high performance chip when compared to the other technology. So it's a free lunch. Don't innovate in architecture, just go and play a technology channel and get the performance improvement. That was the Moore's law. That Moore's law is in, so it's a 2 inches lower. At the same time, Dennard scaling, the power was stagnant. You can see the power was constant line till 2006, when it got incremented significantly. So the power was a problem. Until unless you innovate, you cannot reduce the power. You have a leakage power for adding a circuit and what problem is here. The next is the Amdahl's law. Amdahl's law is okay, fine, I did pipelining. Initially the risk was versus risk in 1986. Then risk I took, risk pipelining I did. Then again I did 5 stage, 8 stage, 17 stage pipelining, all kinds of pipelinings. Then after pipelining is done, I went for a more quantum, core, 32 core, 128 core. Adding a core is not giving me the performance. For example, this graph shows that if you have a 64 core processor, if you keep all the cores working, 99% all the cores working with the number equal to 1, you will get only 1% is the idle time, then you will get only the 35% improvement. It's not at all possible. At the same time, if you keep the 10%, or 90% if you keep all the cores working. For example, mine is a quad core. In the quad core, I keep all the cores, all 4 cores working for 90% of the time. I will get a performance improvement of 5%. For 5% improvement, quad core is a lot of engineering problem, CAD problem, all these things I will do only to get a 5% improvement. So adding a core, now I have a 158 core processor, I will go for a 256 core processor, does not give any improvement. One, analyze your failed, Moore's law failed, then Dennard scaling, we put the limits on the power, then what I have to do? All 3 uses are over, evaluate the architecture. Go back, shift, do the microprocessor redesign, get the new architecture, then sell the IC. So this is what the heterogeneous structures are. The same codes are not required today. I have a core, multiple CPUs over here. I need a GPU, I need the hardware accelerators, I need a FPGAs in the same chip. So this is one example where we have a CPU subsystem where I have a CPU, 4 CPUs, one graphics processor or GPU, one DSP, one boot, one modem, all the things will be there in the single chip. It's not that all the chips must have the same line, maybe different chiplet, but at the same time, all these things, application specific components, I don't want the same, what are these codes? I need a CPU, quad-core CPU, I need a hardware accelerator for ML, I need a hardware accelerator for data sorting, I need a DSP processor, I need a security processor, like this. All heterogeneous things for heterogeneous problems. Then what are the open research problems? RISC-V is coming in big way. It's a RISC-V is a modular architecture. RISC-V is a modular architecture because it's a modular architecture means it's an open source architecture. It's an open source architecture, modular architecture. Why this is coming to the existence? I think I will stop here. Means I have a further few more slides. I will skip functional safety and I will just focus on RISC-V processor. I think it's a time is running out. So the RISC-V processor, why the RISC-V processor? For example, I have bought the system in 2021 and I want to install a 1993 version of Windows on this, and it will support it. I can install it. The question is, in 1977, whatever the x86 came into existence, then it was had only 150 instructions. Now the x86 architecture, whatever the i7, whatever we call it is, has got 3000 plus instructions or 2700 plus instructions. Whatever the instructions designed in 1977 still valid in my computer. So it's an incremental design because some map there I really want to install a version of Windows on the 2025 laptop. So that's the reason it has to keep it. So we cannot help. You have to keep implemental architecture. RISC-V is not an implemental architecture. It's a normal instructions. What is our instructions of this? We just follow additions and modifications. If you want, you can add an instruction, you can delete it. I can design a microprocessor in 2023 and I can use the same processor to install an operating system designed in 2021. Exactly. Exactly. Now there is a bottleneck for x86 and ARM. They have very lot of business for RISC-V for simple reason because they are not modular, they are implemented. They cannot do the downward compatibility, upward compatibility. They cannot give the performance what it is required, what RISC-V can give for each computing, etc. No, sir. The problem is that until unless you have a program with the notion, and dimension, all the incremental designs are over. Once they reach the last unit to become a problem, then even the incremental process architecture is important. That's the reason why the United States, California, Berkeley, for researchers came out that this proposal is a model. So because they understood the 2012 and 2011 majority process architectures are going to be because all these three laws are going to have. The anticipatory from now, the RISC-V is a every company, even Intel has got a RISC-V design, ARM has got a RISC-V design. So it's happening. Exactly, RISC-V supports for Linux. You can install Linux on RISC-V, no problem. Now the Linux is there for RISC-V also. Then another biggest thing is security. We have something called the mental spectrum, which are the attacks which the researchers can look into what exactly it is. Mental spectrum is. Then what is the research problem in security? The post-quantum cryptography, quantum communications, and quantum key distribution. We can make a note of it. The people who want to know the reason. And functional safety is a keyword which I want to discuss, but in the interest of time, I will leave it to you. Then exactly where exactly we can look for other accelerators. Where we have to innovate the other architectures today. How should I design the whole process? For what I should design the whole process? The question is, everybody will tell that I will design a chip for you. I will design a chips for machine learning. I mean, people have tried it, invested it, and done it. What is next after AI? What next after AI? Where should I design the chips? If I want to go a startup, then I want to go and design a hardware algorithms for DNA sequencing. I want do a software design for coding artificial testing. So we do the coding testing in the advanced and mobile time. So that's what we can achieve. So cognitive technology is brain human interface, DCI. We will design solutions in these areas. What next to the AI is these few things. This is my thought process, but I may be wrong. But the literature survey support me. At the same time, software battery management system, process for EV chassis, SOC for EV charging infrastructure is what exactly the electric vehicle is given option. Another biggest thing is digital twins. It's a completely unexplored area for digital twins needs to be run near the architectures. I don't want to get into the digital twins, but I'm just giving you the terminologies. Go and look up for the digital twins for cars, digital twins for equipment, digital twins for anything, whatever the mechanical or the electrical equipment, etc. So go and look at the digital twins and ensure the digital twins are implemented in our digital twins are implemented in servers or APIs for digital twins. Then again, there's a lot of things which can do for security or defense, like insurance, military, etc. Yeah. At the end of the day, the last slide, very important slide is what should be the analytical conditions. Introduce very thorough functional verification and formal verification. Introduce procedure validation. Introduce architectures for hardware aggregation, where you are going to teach how to design chips for neural how to design chips for DNA sequencing, how to design chips for AI, how to design chips for introduce physical validation so that our students get proper results. And again, for all the things, the fundamental thing, what we have to learn and we have to teach is how to write a good example. How to write a good synthesize a good example. Right. Most of the textbooks no teaches. One textbook which I prefer is a trivial prototyping by relevant examples by Point that you can refer from I know very long. I think time is up. Thank you. Yeah. FPGA prototyping by relevant examples. FPGA prototyping by relevant examples. By Point P. It's 2008, 2007 or 8 version of the second edition will be there, but it's only 16 years old book, but you have to build on it actually. You build a path for it, but you have to build on it. The thing is also a good video. How to, it's something like that. Also, we can give an example of how to work on it. Please. Thank you. Yeah. Yeah. Seminars in what aspect? So please visit. Please visit. Yeah. Sir, exactly. 7 levels means it could be 7 metal layers process or 9 metal layers process. So manufacturing is so. The question is ARM has got a 3 versions basically to the best of my knowledge. Cortex A series, R series, and M series. ARM actually. Cortex A, Cortex Y, and Cortex M. Cortex M is for point of sale equipment. Cortex R for EM. Cortex A for data intensive applications like mobile phone and app. It's a 7-layer processing. I'm not very sure about these. What you are asking. 7 metal layers can be there. The 9 metal layers is very common.
Any other doubts? Participants?
Only saturated. Thank you.
Thank you very much, sir.
I can take questions offline. My email ID is there. My email ID is there, and my phone is also available with most of the faculty here. You can write to me, you can call me anytime. I entertain calls.
Thank you very much for insight on the unveiling the semiconductor ecosystem, opening with the semiconductor applications, traditional semiconductor applications, to the research problems in chip design. Thank you very much. And I now request our beloved HOD, the convener of this program, Dr. SPK, Professor TRN, and the team coordinator, Dr. Rudaswamy, and all the other coordinators to join for the felicitation of the speaker.
Sir, I'm very small.
ಮಾಡಿ ಸರ್